this lesson, we are going to look at applying our trig ratios on the Cartesian plane. Now, this is example 1, and what we have here is we've got our Cartesian plane, and then we have the y-axis and the x-axis. So then we also have a point on this Cartesian plane, and we have a distance between the origin and the point, and we have the angle between this line and the x-axis. What we need to find is the distance, r, and also the angle. Now, first of all, since we are working with trig, we want to have a triangle that we can work in. So we are going to draw a construction line from the point down to the x-axis. Now, obviously, we can also create a triangle there, but we always draw the construction line to the x-axis. Also, this theta over here is the angle inside this triangle then. Okay, so what this means then is if this is my x value and my y value, that if the x on the x-axis is 3, it means that this distance here is 3. And then the y, same for y, this distance here would then be 5. Okay, now we have actually a right angle triangle and 2 of these sides are known, which means we can actually now just use Pythagoras. So I'm going to say that r squared is equal to 3 squared plus 5 squared, and then solve for r. So r is equal to the square root of 3 squared plus 5 squared, and that would then give us, so this would then be 9 plus 25. We can just use the calculator there. So we'll have the square root of 9 plus 25, and that gives us square root of 34. Okay, so this r's value is then square root of 34. Now for b, for theta, we need to find the angle. Now we've done this before, just not on a Cartesian plane, but to find that angle, we can use our trig ratios. Now we can choose whether we want to use either sides. We can use the opposite and the hypotenuse, or the adjacent hypotenuse. But if you have a choice, always try to use the ones that they already gave you, just in case that our answer here is wrong. That would make your second answer also wrong. So always try and use the ones that they give you if you can. So the ones that are given are the opposite and the adjacent, and the ratio that includes both of those are tan. So tan of theta is equal to 5 over 3. And then to solve for tan, for theta, we have theta is equal to the inverse of tan of 5 over 3. And then we just type that in. So this would be shift tan 5 over 3. And that is equal to 59,04. 59,04, and that is a angle, and that is then example 1. Now for example 2, we have the same story. We are given the x value, and we're given the angle in this case. So once again, I'm just going to construct this line in here, and then we know that the distance here is 2 square root of 3. And this one is y. It's not given the distance we need to find in b. So r, now we can't find Pythagoras or use Pythagoras because we don't know this side. But we do know this angle, so we're going to use our trig ratios. And the applicable trig ratio that we're going to use is the one that contains adjacent and hypotenuse. So that would be cos. So cos of 30 is equal to adjacent over hypotenuse, so that's 2 square root of 3 over r. And then I solve for r, meaning I use cross multiplication, so r goes up and cos 30 comes down. So r is equal to 2 square root of 3 over cos 30 degrees. And that then is equal to 2 square root of 3 over cos 30, which is equal to 4. Right, b, we need to find y, and here we have a choice. We can use Pythagoras, although I would go the safe way and rather use the information that's already given. we can use the trig ratio, which contains the opposite side and the adjacent side, and that would be tan once again. So tan 30 degrees is equal to y over 2 square root of 3, and then we solve for y, so y is equal to 2 square root of 3 times by tan 30, and that then is equal to and that's equal to 2. Okay, so that's it for example 2. Now for example 3. So this one is slightly harder because we can see that we are now working in the second quadrant. So our angle is actually, and remember the angle is also always measured from this first quadrant, from the 0 degrees going around anti-clockwise. Okay, so here we construct our line, and we know that this is our x value and our y value. Now, since we have a minus 7 because we're going into the negative, think of a number line. This is 0. This was your positive values, and now we're going into the negative. And the distance is still just 7 because we are interested in how far this is, or the distance here. And then this is going to be a 5. Now, we can then, for Pythagoras, we can use Pythagoras to find r once again. So r squared is equal to 5 squared plus 7 squared. And then solve for r. R is the square root of 5 squared plus 7 squared. And then just calculate that. So that's 25 plus 49. So that's equal to 74. All right. So this guy is then equal to square root of 74. Now for alpha. Now this is where the trig comes in. There's two ways to do it. We can just type in the trig ratios and with their signs, or we can name this angle alpha 1, and then we can calculate alpha 1 just using this concentrating on our triangle as we do normally, and then just take 180 minus alpha 1 to find alpha, because these are angles on a straight line. So I'm going to go about that route. I'm going to start by finding alpha, and this is opposite over adjacent, which is tan. So tan of alpha 1 is equal to 5 over 7. Okay, and I just use my normal numbers, the numbers without their signs. All right, so then we have alpha 1 is equal to inverse of tan of 5 over 7, and we calculate that. So we have shift tan 5 over 7, and that gives us 35,54. 35,54. Right, now we can just find alpha by saying 180 minus alpha 1, and then we'll have, so I'm just going to say minus 180 is just still the difference. We just use a positive value, 144,46 degrees. Okay, so this is then alpha's value. Right, now for example 4. So now we are actually working in the third quadrant. And once again, let's construct our line, and remember to always take it to the x-axis. And we know this then, the distance here is, this is my x value and my y value. So the distance here is 3 and the distance here is 2. And then to find r, that's pretty easy. We can just use Pythagoras. So r squared is equal to 2 squared plus 3 squared. And r is the square root of 2 squared plus 3 squared, which is 4 plus 9. So that's just 13, square root of 13. Okay, and then for b, we need to find beta. So once again, I'm just going to concentrate on my smaller triangle. I'm going to call this beta 1 and find beta with opposite over adjacent. So that's tan. So tan of beta 1 is opposite 2 over adjacent 3. then beta 1 is equal to inverse of tan of 2 over 3. And that would be shift tan of 2 over 3. And that's equal to 33,69. So 33,69. Okay, so beta. Now, remember, this is now the whole angle. And we know this is a straight line. This from here to here is 180 degrees. So to find the entire beta, we're going to say 180 plus the beta 1's value. So the total of beta is 180 plus the 33,69 degrees, and that would then give us, so if I just add 180 here, then I get 213,69 degrees. Okay, now the next one is to find sine beta. Now in this case we have to use our sines, okay? We are still thinking of just working out of this angle over here. So just don't, we're still going to find beta, but we're working out of the same angle here. All right. And sine we know as opposite over hypotenuse. Our hypotenuse here was 13, right? So sine beta 1, or sine beta actually, because we want to find the whole of beta, and that's what makes the sines quite important, to remember to include your sines. So this is then, and remember this distance here will always be positive. It's only your x and your y values that will sometimes be negative depending on in what quadrant you are in. Okay, so sine is opposite over hypotenuse, so that means minus 2 over hypotenuse is square root of 13. All right, we're just going to simplify that because we never leave our answer with the square root in the denominator. So I'm just going to put that in as minus 2 over square root of 13. So that gives me negative 2 square root of 13 over 13. So negative 2 square root of 13 over 13. Okay, then D. Now D is cot. So this one, what we do with our ratios, if we have tan, we know tan theta is opposite over adjacent. Now cot is the reciprocal to tan, meaning if I want to find cot, I'm simply just going to swap these two around. I'm going to say cot will then be adjacent over opposite. And same with sine and cosec. Sine is opposite over hypotenuse, so cosec would be hypotenuse over opposite. So that's basically what we do there. So for cot beta, I'm going to say adjacent over opposite. So adjacent from this angle over here, adjacent is minus 3 and opposite is minus 2. So I just simplify that and that becomes 3 over 2.